And we get introduced to well, actually 6 new identities today that you can use in proofs. But these identities are special because they have other applications. Now, these are the most scary looking identities because they use 2 new Greek letters, alpha and beta. Does that make them scarier, don't you think? Yeah? And like, look how long they are. Sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. So what does it mean? Well, if I would take out my graphing calculator, and I would let's just start with them being all the same. So I'm going to write sine x cos x plus cos x sine x. And so what I'm doing in my graphing calculator here is I decided alpha is x and beta is x. And if in this first formula I wrote sine x cos x plus cos x sine x, and I go to my calculator and I graph it, and this little mark is 2 pi that I made on my graph. Can you see that it looks like a sine graph? Goes from 1 to -1, has that amplitude. Except, what's the period if it does 2 full revolutions from 0 to 2 pi? The period would be pi. Make sense? So if it does from 0 to 2 pi, if it does 2 full revolutions, that's like you took from 0 to 4 pi and compressed it by a half. How do you show a compression by a half in your equation? That's horizontal. You put a 2 in front of the x. So if I go to y equals, and I now try to graph sine 2x and hit graph, you notice the red line is perfectly over top of the blue line. So sometimes when in years that we have more time, I actually have a graphing calculator activity that I get you to do a bunch of these. So the next one you would try, you go back to your calculator, you would put in 2x and x. So sine 2x, cos 2x, and then cos 2x sine x. So what I've done is I replaced the alpha with 2x and the beta with x. According to the formula, that should equal sine of 3x. Again, if we go to our calculator, here's something for your calculator. I don't want to erase this because I'm going to use it again when I type in 3x, but I don't want to have it graph. So if you go to the equal sign and push enter and turn off your equal sign, it won't graph it but won't have to delete it. So now when I hit graph, can you see between 0 and 2 pi you have 1, 2, 3 periods now? Would have been a horizontal compression by a third, which should match up if we put a 3 in here.
So alpha and beta are just different factors of compression?
Alpha and beta are just different variables. Saying you have 2 different angles, you could combine them together. So for example, if you wanted to find sine of 60 degrees, which you know is root 3 over 2, you could do 30 degrees plus 30 degrees here. And if you did sine of 30 degrees multiplied by cos of 30 degrees and then added cos of 30 degrees and multiplied by sine of 30 degrees, you will get 60 degrees. Okay? Now, that wouldn't be very useful because it's much easier to find sine of 60 degrees directly. But there are going to be some angles that we can now find, and part of this, we'll get to it probably this afternoon's class. We're going to have some angles we're going to be able to find that we couldn't find before. For example, what's sine of 15 degrees? That's not on your pie plate. In fact, if you think about your pie plate, between 30 and 45 is 15 degrees, right? And 45 and 60 is 15 degrees. But between 0 and 30 is 30 degrees. You're missing an angle in there on your pie plate. You're missing 75 degrees. But 75 degrees is the same as 30 degrees plus 45 degrees. So if you wanted to find 75 degrees here, you could put 30 and 45, 30 and 45. And on the right-hand side, those are all on your unit circle, and you could figure them out. So this unit does use your unit circle a lot as well, but like I said, you're allowed to use your pie plate for this unit. Okay, so with that in mind, we are actually going to start with example number 2. And with example number 2, I'll bring it to you. And by mostly memorized, I mean that you need to be able to recognize that, oh, if we have sine cos and cos sine, that's probably one of my formulas. All of those formulas have 4 sines and coses combined together. So if you have that, then you go, hey, I should check my formula sheet. That's mostly memorized. Completely memorized is you would look at that and say, I know it's my sine alpha minus beta formula. That's completely memorized. But mostly memorized is I see 4 sines and coses together with adding or subtracting in between. It's one of those formulas. Which one is it? Is there one if I make this alpha and this beta, this alpha and this beta, is there one that matches up? You look at your 4 formulas, and you recognize it matches up with sine alpha minus beta. Then you can simplify A by writing this, which is the right-hand side of the formula, as alpha minus beta, the left-hand side of the formula. And what's 8x minus 3x, since those are like terms? Sine of 5x. So we have alpha and beta formulas. These are called sum and difference identities because on the left-hand side, you're either adding 2 angles or subtracting 2 angles. So that's the reason they're called sum and difference identities. If we just look on the page before, you'll also see, no, that's not the page before. Here we go. You will also see the sum and difference identities for tan. If you add 2 angles inside of tan, if you subtract 2 angles inside of tan. How do I mostly memorize these? I go, if I see a fraction with a lot of, that's a nicer word than I was thinking, a lot of tans. If I see a fraction with lots of tans, it's probably one of those formulas. So then I should check it. But you have to train yourself to have it mostly memorized that you're checking, because if you don't check and just continue on trying to work through something else, then you're going to make the question very, very difficult. So let's go back to B now. We have tan plus tan minus 1 minus tan. That's a lot of tans. So you say, if this is alpha and this is beta, alpha, beta, is there a formula that's tan alpha plus tan beta over 1 minus tan alpha tan beta? Yes. That is the tan alpha plus beta formula. And so for B, we could now write this side as the right-hand side. Alpha's pi over 6 and beta's pi over 12.
So now we can swap these out when we're solving in just one step?
Yes, you can swap that out in one step. And sometimes there's going to be proofs that are going to have this in them. Now, everything else that we've used in proofs so far, probably with the exception of like the tan squared plus 1 equals secant squared, that all came from chapter 6. But this is completely new. Now, if you wanted to put that together, you could. How do we add fractions? Need a common denominator. This is 2 pi over 12 plus 1 pi over 12, which will be 3 pi over 12. Right, you don't have to simplify fractions in grade 12, but if you don't recognize that that's pi over 4, And tan of pi over 4 is 1. So we can evaluate that big expression because it's simplified to something that was on our unit circle. Okay, questions for practice on this one? Numbers 4 and 5.